Yeah, this is
fun to watch.
This is really fun to watch. I think it's interesting, especially in a class like this, because we keep talking about computer games and stuff like that. So everybody is just sitting down, playing games. So when they drive, they're just going like that. Now this is driving.
Oh yeah, I already like it.
JubiCon is fun stuff.
And just observe how calm he is. He was the whole time. That's
the best part. It's a souped up Fiesta.
Yeah, super.
Yeah.
And people would think it's a video game because they would think it's not possible to drive like that. Not street legal. It's just fun to watch. Just look at the course. Okay, here's the fun part. He has to knock out all the balls. But not crash the car in the process.
I think it's just set of tires.
And then they start to move. The Lamborghinis are now moving. You can hear the turbo. Now here's more fun. Watch this one.
Those guys have nerves of steel, though, to say the least.
Well, they probably have done this many times already.
It doesn't matter.
Now this is also interesting. The crane is moving. And look at this guy. He's just calm. He's like. NASCAR, anyone? Now, what I think is kind of interesting is there are several things about this that I think is really, really interesting. One, if you look at the sponsor, Need for Speed, that's a game, right? That's a video game. So they're putting this on YouTube, just so that people can get excited about driving. But most people cannot afford a car like that with 600 something horsepower and a whole crew to repair the car, basically on a daily basis, right? Or have a neighborhood that can tolerate this kind of driving. So now we have a lot of people who want to do something like this, but on a computer. Yeah, the gaming industry is now bigger than the movie industry by a good margin. And it will continue to be like that. In other words, in a few more years, the movie industry will be small by comparison compared to video game industry. I'm not sure how many of you here have any inclination to get into the gaming industry. Anyone? Okay, quite a few. Okay. I think that's an area that will definitely continue to grow. It's really quite interesting. And then the second thing I want to point out is I kept talking about self-driving cars in this class. Remember, I don't think that kind of driving can be automated anytime soon, because it still takes a lot of input, a lot of stuff that only people can do. Basically gauging and evaluating what to turn, when to let go of the accelerator and stuff like that. So just for driving, there's driving that computers can do, and then there's driving that computers cannot yet do. He is a superhuman in terms of driving. I mean, Ken Block, for those of you who don't know his background, he used to be an extreme sport athlete. So he does skateboarding, BMX, and that type of thing. And then they got him into a car once and say, well, since you're so good with skateboards and stuff like that, you want to try this one out. And he found out that he's really good at driving, because he just has an extremely good sense of G-force. So he knows when things are losing traction, and he knows his direction. He can figure out, he can track his own motion. So it's just kind of interesting how some people can make a career change. And all of these other videos are for Need of Speed, the video game itself. I mean, that's basically, just for getting people, trying to hook people into that type of games. Okay, any questions? No questions. You guys are all silent. All right, but I just wanted to show it because it's kind of cool, and who knows how many computers are actually in that car, controlling for engine control and all the other stuff. No small control though. All right. So I think most of you did the homework assignment, the extra homework thing that I sent out to you guys. So I'm not going to go over it. I think most of you get it already. But the program actually tries to figure out the Fibonacci numbers. That's basically what it does. So if you get 0, 1, 1, 2, then you got it right. Okay, and if you continue, if you make the array a little bit bigger, you would just get all the other numbers after 0, 1, 1, 2, and so on. All right. So what we'll do today, first of all, an announcement on Thursday. This Thursday, we'll have a practice test for exam 2. And then next Thursday, we'll have the actual exam 2. It will cover everything up to, in this class, we'll cover up to local variables, but not parameters. Okay? Any questions about the scope of the second exam? Okay, I will send you guys a note too, as a reminder. We
have
are.
a question over here.
Oh, okay, go ahead.
Are you doing the pre and post conditions?
Oh yeah, we are starting from the pre and post conditions and cover everything up to local variables.
Okay.
Yep. So it's not comprehensive in the sense that stuff before the first exam, I would not specifically test those things, but they will still be included because we will still have conditional statements, loops, and other things. So it's not intentionally comprehensive, but it does include the other topics. Any other questions? Same things, open book, open notes, bring anything that is either printed or handwritten prior to the test if you think it's going to help you. Was it helpful? I mean, did you guys bring a lot of stuff that, that was helpful to you? Or so if it's not open book, it would have made a difference?
It's more like the preparing of the notes that's helpful.
Uh-huh. So, but once you have it, you don't
Yeah,
really
you
have to
don't-
refer to it too often.
Yeah, but I don't know if I prepared if I didn't have it.
Well, that's good. I mean, you're using the opportunity to prepare for the notes that you bring as a chance to study. Well, that's really a good thing because in case you need it, you know exactly where to find it. Yep. Excellent. Right. So we are still on subroutines, and this is the updated notes. We are done in this particular class, in the PM class. We are pretty much done with by value parameters. So now we are moving on to something that's a little bit more complicated, which is by reference parameters. Starting with section 6. I think we probably can cover by reference parameters today in this class, which means starting on Thursday and also next Tuesday, we'll be getting into returning values, which is actually a very important and useful topic too. All right. So we'll start with a sample program that for most, it does something, but then it doesn't do anything either. Okay, so we'll start with a program that has a problem. Okay, it has a certain intention to do a certain thing. It gets most of it done, except in the end, it gets nothing done. Okay, so we'll talk about this kind of useless program, and then we'll find out how to fix the program pretty easily. So we'll have an exchange or swap subroutine. We already know what swapping is, because of a earlier question in the exam or one of the homework. So we'll go ahead and say, we have two by-val parameters. We'll call that, x and y. And then we have a local variable t. There's no rule against, having local variables and by-value parameters, in the same subroutine. You can have any mixture of by-value parameter, local variables, by reference parameter, and by reference parameters. Okay, so I'm just going to give you the code here. T gets the value of x, x gets the value of y, y gets the value of t, and that's it. Okay, I'm pretty sure we have seen this before. Have we talked about this kind of code before? It's exchanging the values of x and y, basically. Okay, so now outside here we have two more global variables in this case, or I can try to avoid the use of global variables altogether. Now we can do something like this. Now this is a kind of interesting name for a subroutine, but I'll explain that. So we have local I and local j, and we can make I start with a particular value. Let's make I start with 3. And j start with, 30. And then we'll go ahead and invoke the subroutine swap. When you invoke a subroutine that has parameters of any kind, you always have to specify the parameters. In this case, we have two parameters in swap, parameter x and parameter y. So I'm going to use variable I in main to specify parameter x. I'll use local variable j to specify parameter y, and define sub, and then out of this whole thing, we just say invoke main, and that's my entire algorithm, the entire program. We're going to trace this after I talk about the significance of the main subroutine. Okay, so right now, we are kind of shifting gear into getting you guys ready for the C++ programming class. Not that we haven't been doing that before, but this one is a standard that you have to understand in C programming. In C programming, there's no such thing as line 16. In other words, everything that you specify, every single line of statement, has to be in a subroutine. Well, but if everything is inside the subroutine, according to the standard that we use in this class, where do we start execution? Remember, the first line that we execute is the first line that is outside of the definition of a subroutine. But if everything has to go into subroutines, then how are we going to start the execution of the entire program? Well, the main subroutine by default in C and C++ is the starting point of your entire program. In other words, the subroutine called main has a special meaning. Okay? It is called main because it is the first subroutine that is quote unquote called by the system itself. So nobody has to call it. It is simply the first subroutine that is invoked. Okay? In other words, in the C program, line 16 is actually implicit. It is done without your code. You only have to start writing the main subroutine, and that's it. And the name main is actually a C standard. Are we doing okay so far with that particular convention? Is that okay? All right. No? Kind of? All right. But in this class, we're still using that convention that we have to start execute. The execution of a program has to start on a line that is outside of the definition of a subroutine. And that's why we still have line 16 here, just to be consistent with everything that I have talked about so far. Yep.
If you're invoking main, if you're invoking main, how come you didn't name main? You put define sub main.
Yeah, that's main.
But shouldn't it have its own name if main is its own declaration?
This is the entire definition of the main subroutine, starting from line 9 all the way up to line 15. That's my main subroutine.
Right, but what I'm saying is for instance, the one above it says
Swap.
swap, and so shouldn't this say, have its own name if this is going to be the main? I mean, in other words, you're calling this the main, just like you would with C, is what you were saying.
That's from line 9 to line 15. That's the main subroutine.
Which should be the first line
No,
of code.
no.
You're not
That's
saying
no.
that's what it is. Okay.
The ordering does not matter. In fact, most of the time you want to define the subroutine that you're invoking first in C, because otherwise you have to use a prototype. You have to use a function prototype to say that, yeah, there is a function like that, but I'm defining it later. All right, so let's go ahead and run this program and see why it is useless, because it is almost doing what I wanted to do, but it's not quite there yet. Okay, so we start the execution of this program. We start with line number. There are no conditional statements to evaluate, so we don't need a comments column. Are there any global variables? In other words, if you look at X, Y, T, I, and J, do they have a corresponding declaration that will basically make them not global variables? Does every single name have a special declaration in this case? It looks that way. I mean, it looks like inside swap, X is a by value parameter, Y is a by value parameter, T is a local variable. So every name that I use in swap is accounted for. Inside main, we have I. It is a local variable. We have J, which is also a local variable. So every name is also accounted for. So we don't have any global variables anymore. Yay, that's a good thing. Okay, but you will see later on that we have a problem that seems like we cannot solve that problem without global variables. So we'll go ahead and trace the program first, and then we'll find out why there's a problem with this program. Okay, we start with line 16. Line 16 is just invoking main. We have return line number being post because there are no lines after line 16. And then we have the local variables inside main taking up some columns. We have column C and column D taken up by the two local variables I and J. As local variables, they always start with an unknown value. And then we can continue execution in the subroutine, in this case in main, starting on line 12. Line 12 and line 13 are pretty easy. We're just initializing our local variables. I gets a value of 3, J gets a value of 30. Oops, not on the same line though. So on line 13, J gets a value of 30. And we are done with most of the code in main already at this point. Line 14 is not too big of a deal. I mean, it is the first time we see a mixture of local variables and by-value parameters, but it doesn't change the way we do things, okay? In this class, if you want to declare t first and then x and y, I'm not going to take any points off, okay? The ordering in the columns doesn't matter in this class. In cisp310, it does matter, okay? But this is cisp300. We are a little bit more relaxed, so it's okay either way. Personally, I always put the parameters first. So we have x, y as parameters, and then t as a local variable. T as a local variable is easy because it always starts with an unknown value. The return line number is also kind of easy because the invocation is on line 14. We have to go back to line 15 to continue execution in main. What we want to know, what I want to know, is what value do I use to initialize parameter x and parameter y? What do you guys think?
I for x and j for y.
Correct, but we do not say I here and j here. Okay, we have to look at the values of I and j.
30, sorry.
So we have 3 and 30 here. Okay. So are there any questions about how these 4 columns are first allocated and then initialized with the values that they have now? Any questions? No questions? Okay. All right, so if there are no questions, we'll move on and continue into the subroutine called swap. On line 5, we do the 3. Yep, go ahead.
Since the I and j got values within main,
Yes.
they should be only used within main. Same for swap, right?
Well, I and j are variables that are local to main.
I know, but there's a cross-reference to x and y.
It's not a cross-reference. On line 14, because line 14 is still in main, right? So that's why on line 14, I still have access to the local variables I and j. Now, the names x and y, as parameters, they are quote-unquote exposed because I'm invoking that subroutine. Because remember, the by-value parameters are like inboxes. So it has to be visible from the outside as well as from the inside. Local variables, on the other hand, are just visible from the inside because nobody from the outside should be able to access them. Now, what is important here is even though x is related to I, the relationship is simply that x, the initialization of x utilize the value of I. That's the only point where these two concepts cross paths. Because after that, x becomes its own independent column, and y becomes its own independent column. So in the rest of the code, from starting with line 6, it'll be clear. Line 5 doesn't really show you very clearly how the variables and the parameters are completely independent. In this case, on line 5, we copy the value of x to t. X, which is column F, has a value of 3. So t as my local variable in swap will now also have a value of 3. That part is not mysterious because a local variable is a local variable. What we have to think about is what do we do on line 6? Because line 6 is kind of interesting because we are now copying the value of y, the right-hand side, to x, which is the left-hand side. Y is not an issue as on the right-hand side because we just have to evaluate the expression and say, okay, what value are we dealing with here on the right-hand side? Y has a value of 30, so the right-hand side of the assignment statement on line 6 is simply 30. The question is, we are supposed to store that into parameter x. So what are we going to do? Well, x is now occupying column F, and that's why we are going to overwrite column F. We are not overwriting column C, which is the column corresponding to local variable I. Are we doing okay so far? Okay. So the linkage between I and x and also j and y is gone as soon as the invocation happens. Okay. It's only used to connect the two, but once the connection is done, we are just x is a copy of the value. So on line 7, it's not going to be that much of a mystery because on line 7, the right-hand side is t. T is my local variable and it has a value of 3. We want to store that to y. Y as a bivalue parameter has its own column, which is column G. So column G is now updated to a value of 3. In other words, if you look at lines 5, 6, and 7, they succeeded in exchanging the values between x and y. X used to be 3, y used to be 30. After lines 5, 6, and 7, x ended up with a value of 30, and y ended up with a value of 3. So it seems like the swap operation was successful. It actually got the job done. And then here comes line 8. Line 8 is doing what we usually do at the end of the invocation. First of all, we locate the rightmost return line number, so we know where to go back to. It says line 15. We make a note. Okay, we will continue on line 15. And then what we do is we deallocate everything that was allocated on a per invocation basis. So in this case, all 4 columns are deallocated. In other words, by the time we continue execution on line 15, nothing happened to I and j. Right? But when you look at a subroutine swap, it doesn't seem to make a lot of sense to only exchange the values between the parameters x and y. It seems to make more sense that maybe we wanted to exchange the values between I and j and not so much between x and y. Okay? And that's why this program is not doing anything, because by the time we get back onto line 15, nothing happened to I and j. They are not exchanged. Okay? So on line 15, it's the end of the subroutine, so we have to do pretty much the same thing. Make a note that we have to continue execution at post, and then deallocate the 3 columns that we allocated for the main subroutine. And that's the end of this program. It's incorrect because I wanted it to exchange the values of I and j, but other than that, it's not going to crash. It just doesn't do anything about I and j in the subroutine swap. Are there any questions about this trace? Yep.
On line 14, when you during the sub main, when you assign the columns for x and y, how did you assign it to t for h? Because we're still in sub.
Okay, on line when we executed line 14, we created these 4 columns, right? Return line number, x, y, and t. The return line number is easy. X is a parameter. It gets the value from the expression I here. Y is a parameter. It gets its initial value from the expression j. And t is a local variable, and that's why it starts with an unknown value.
But we're in main. We're not in swap yet.
At
Right.
this point, we are transitioning between main and swap, but technically we are in main, but we are also doing the allocation in swap too. In this class, we don't make a distinction. We just say that we are, preparing for the execution in the subroutine when we execute the invoke statement. In cisp300, then we make a distinction of which part is done by main and which part is actually done by swap. Okay, that's a good question, but it's the full answer to that question is going to be in cisp300. Okay, any other questions? Now the most important part about this, and I know somebody in this class in a homework assignment is going to do this, is not to put I in place of 3 and put j in place of 30. That would be incorrect. You have to actually use the value. And that's why these parameters are called pass by value parameters, because the inbox is not actually an inbox. Okay, the so-called inbox is more like a copier. Okay, if you want somebody to process a form for you, you basically put the form on the quote-unquote inbox, and then there's a button that says copy. So the person inside the office doesn't actually get a hold of the original item, but a copy of the original item. So the person inside the office can do anything he or she wants to do with the copy, but nothing happens to the original. Is that okay so far? All right. So it seems like we are missing a concept in order to accomplish something like this. We want to exchange the actual variables I and j, but we cannot do that using just local variables. and pass by value parameters. So I'm gonna change this program a little bit. I'm gonna save it first, just so that we have a copy of the original. So we'll just call that local. And now we'll save it again as by reference. I should have saved it as by value.
Can you pass
Okay.
the roll sheet? Roll sheet.
Yep, I got it. Brand spanking new row sheet here. All right, so the fix in terms of syntax is very simple, but in terms of the actual implementation and how it is done is a little bit more complicated. So this is one of those things, where, today would be a good day to be here and pay attention, because this is one of those things where, if you miss a class, it's going to be a little bit hard to catch up, because in terms of syntax, this is one half of it. The other half is down here. I'm going to change the single-sided arrow to double-sided, and that's it. Those are the only changes I'm making syntax-wise. Okay, so when you look at this quote-unquote new program, at first glance, it doesn't look that much different from the other one. Okay, I'm not adding any additional lines. I'm not changing the flow of the program. I'm just syntactically changing the name by val to by ref, and I'm using double-sided arrows instead of right arrows when we invoke the subroutine swap. Okay, so the key is not the syntax change. The key is inside the trace itself. So we'll go ahead and start, let's see here. We'll restart the trace from here, okay, because line 12 and line 13 are not affected by these changes yet. But on line 14, when we execute line 14, we'll start to see something that is a little bit different. All right, so this is line 14, and on line 14, what we'll do is, hey, the same thing here. Return line number is still doing the same thing that it's supposed to do to indicate where we are supposed to go back to. So we are still supposed to go back to line 15. That part has not changed. If you look at local variable t, it is still a local variable starting with an unknown value. That still has not changed. What we're going to change is x and y. Okay? But even the fact that we have to dynamically allocate a column for x and another column for y, for in a per invocation basis, even that has not changed. So what we are changing is what exactly is x and what exactly is y in this case. For the lack of a better word to describe it in this class, I'm going to use the concept of an alias. So x is now an alias of not I, but column C. Okay? And I'll explain this, just give me a second to finish this one here, aka also known as column D. Okay, that's in bad grammar here. There we go. Okay, so this is it. Okay, I have just made all the changes that I need on line 14 when I execute line 14. X does not have a value anymore. X is now an alias of column C. What is the other name of column C at this point? I. Okay, so at this point, I, which is a local variable in main, is a name of column C. But X, which is a pass by reference parameter that belongs to swap, is another alias, is another name of the same column. Okay? Are there any questions at this point? I know some of you are already thinking ahead and say, so what do we do when we assign something to X or to Y? What do we change? We'll get to that later. Okay? But the most important part is X does not have a value anymore. Y does not have a value anymore. They become aliases of the other two columns. If you look at the grand scheme, if you take a step back and look at the concepts, the columns, okay, column C, column D, column E, and so on, each column is actually corresponding to a memory location inside the computer. I, J, X, Y, and T, those are simply names that we use to refer to the columns. Okay, because it's handier to be able to assign user-friendly names to the columns. Yep.
In real programming, what would that little double arrow be?
The double-sided arrow, they'll be missing completely because in most programming languages, when you pass parameters, you don't pass parameters by specifying what name, the name of the parameter. It is done by position. But in this class, I'm making very clear that we are using I to specify parameter X, and I'm using J to specify parameter Y. Okay? So that's a syntax specific only to this class. All right, so we're moving on into the subroutine swap starting on line 5. Line 5 is a little bit different from last time, but it's not too mysterious because the right-hand side of line 5 is simply referring to X. So you look up the column that is labeled X, and it tells you that X is an alias. It is also known as column C. So what do you do next? You look up column C, right? And column C does have a value of 3, and that becomes the right-hand side of line 5. And we are just going to use it to change T, which is a local variable, just like in the previous trace. So line 5 is not that much different compared to last time. It is a little bit different because now you have to track down not only column F, but also column C as a result. But what is really changed is line 6 and line 7. Line 6 on the right-hand side, pretty much the same thing. You look up the column with a label Y. It says, okay, I do not have a value because I'm just an alias of column D. Then you look up column D, and column D has a value of 30. So we know the right-hand side of line 6 is just the value of 30. So that part is not too bad. But we are now storing that value of 30 into X. So here comes a real question. What do we do on this line when we are supposed to store something into X? You look up X, it's not too hard. I mean, we do have one column, column F, that has a label X. And it says, I'm an alias. I am also known as column C. So the question now is, do we update column F, or do we update the column that it refers to?
The one it refers to.
The one that it refers to, that is exactly it. So as a result, when we store something into X, we are changing the column that X refers to. In this case, it's column C. So column C is the one that is changed to 30. How many people watch Stargate, SG-1, and all the other ones? Any Stargate will work. A pass by reference parameter is a gate. That is active. Okay? So you open up a wormhole, okay? And when you access something through the gate, it is not in your space. It's not in the base under the mountain. The other side can be anywhere. Okay? So when you overwrite something, you're also overwriting something that is not in your room. You're not overwriting the gate itself. You're overwriting what the gate is connected to in this case. Are we doing okay so far with that analogy? How many people are still not getting it because you're not a Stargate fan?
Maybe if you try Star Trek.
Okay, well, in Star Trek, let's see whether they have similar concepts. Yeah.
You have wormholes in Star Trek.
Yeah, they do. But a Stargate is really kind of interesting because you can put a Stargate in a room, in an office, right? And when you reach into an active Stargate, it is actually on the other side. I mean, you're getting things that are not inside the room itself. Okay. Well, actually, later on, I can give you a different analogy, and that one should work with most people. Okay, here's line 7. So we'll finish the trace first, and then I'll use the library example. Okay, that one will connect. Okay, so on line 7, we have the opposite. The right-hand side is T, which currently has a value of 3, and we want to store that value to Y. You look up the Y label Y. It is an alias of column D. So column D itself is now updated to a value of 3, and we're done. Okay, now we get to line 8. Line 8 does exactly the same thing as last time. Everything that we well, first of all, we look at the return line number, make a note of it. But everything that we allocated for this invocation will now be deallocated. But heck, if we're deallocating everything, including x and y, wouldn't that undo what line 6 and 7 did already in this code?
No.
The answer is no, because
It's a reference, not a.
you're destroying the alias. Okay, you're deallocating the alias, but the column has already been changed. So it's okay, it's no big deal. It's kind of like, having done something to the other side of the wormhole, you destroy the Stargate. Well, you can destroy the Stargate, but it doesn't do anything to the things that has been done already on the other side. All right, so back to line 15, this is pretty much the same stuff here, but the most important part is by the time we get to line 15, you can see that I and J are now exchanged. But all done without the use of global variables. Okay, so that's the most, this is also important because by reference parameters, we can basically almost eliminate the need to use global variables. So on line 15, we'll just finish up the program because this part is pretty much the same as last time. We take note that we have to continue execution at post, and then we deallocate the 3 columns that we allocated for this invocation. So we go to format cells, strike through, and we're all done. Are there any questions about this? Yep.
Why go through the trouble and do all this when you could just assign 30 to I?
Well, this is an example, because sometimes you want to exchange items in an array. So in that case, you cannot have unless you want to kind of replicate the code everywhere, you would have to. This would be the easier way to do it. You define a subroutine to exchange the values of 2 variables, and then you can apply that to any 2 variables that you encounter. So in this program, yes, it's not very useful, but I'm using it only to illustrate the effect of passing by reference as opposed to passing by value. Right. I did promise you, the different analogy that is not referring to Stargate. Okay, nor Babylon 5. Babylon 5 also has the concept of a gate, but this time we'll use the library. Okay, so here it goes. So let's say somebody is it's a proofreader. Okay, so let's say I'm a proofreader, and the proofreader is a subroutine. Okay, you give me a book, and I'll proofread it, mark it up, spelling, typo mistakes, and whatnot, okay? And that's my job. As a proofreader, do you think the book that is passed to me should be passed by value or passed by reference? Because obviously, I'm not going to proofread a particular book. I will proofread whatever book you give me to proofread, right? That makes more sense. I'm not going to proofread the same book over and over and over again. It's not hard-coded. Okay, so now the question is, the book that I'm supposed to proofread, should it be passed by value to me as a subroutine, or should it be passed by reference to me as a subroutine?
By reference.
By reference, why do you want it to be passed by reference?
It's not alter the original book.
Exactly. Okay, so let's think about the 2 alternatives, okay? If you pass by value, if that book is passed by value, then what you're doing is you're putting the book on the quote-unquote in tray, but remember, the in tray is not an actual in tray. You place the book on the in tray, but I don't actually get that book. I get a copy of the book that you put onto the in tray. All right? So I would take the book that is a copy of the original. I will do all the work that I need to do, read every single page, mark it up, rip out pages that I think should not be there, and so on and so forth. So at the end of the entire process, I would have a book that has all the comments, edited and whatnot. What do I do with that book? I dump it into the recycle bin. Okay, the recycle bin is the best analogy because the columns do get reused later on. Okay, so what do you get as the person who gave me quote-unquote the book to begin with, to proofread? You get the same book back because I never knew how to get to your book. Okay, I only got a copy. That's passing by value. So exactly what is passing by reference, but without any references to Stargate, terminology? It's easy.
Give you the title?
Hmm?
Give you the title?
No. Well, very close. You're very close. Okay. What I had in mind is you give me, instead of the book on the copier, you give me a call number. Okay. You wrote down the call number of that book on a little slip of paper and you put it into my in tray. So what am I getting on the other side of the in tray? A copy of
The location
the
of where
call
book-
number. Okay, I have a copy of the call number. Okay, now as a proofreader, what do I do with the call number? Do I proofread the call number itself?
Now you look it up in the book and do you
Exactly. I use the call number so I can go to the library to check out the actual original book, where I would do all the work. At the end of the entire process, okay, as a subroutine, I'm supposed to destroy something, right? I need to put something into the shredder. What do I put into the shredder in this case?
the call number?
The copy of the call number, okay? To be exact, it is just a copy of the call number. Is it okay to shred that, call number in the shredder?
Sure.
Yeah. What happened to the book in the library? It's modified, right? Because in the process, I'm actually using the original book because I know where to find it. And that's what a reference is. A reference is a way to find something. Okay? I just called it an alias in this class, but what it is a way to find the original item. In this case, in this class, it is a way to find a column. Okay? Where is that column? Are we doing okay so far with the library analogy? See, I told you I can go old tech as well. No Stargate, no electronics, it's all.
Thinking more like a parts warehouse. Works a little easier for me.
Okay, well, it's the same thing. They give you a location code
Yeah.
so you know where to find it. It's like, oh, here's a little slip of paper of a location code, clean all the parts in the bin, okay? So they're not making a replicate of the bin and all the parts in it for you to clean and only to get it recycled. They're giving you the location where to find what you're supposed to work on. Okay, so that's good, very good. So just when we think we know what it is, I'm going to give you an example that might shatter some of that to believe. Just some, not all. Okay. Define sub 1, and iref x gets x plus 1, and define sub 2, iref y. And this time I'm going to do something interesting because I'm going to invoke sub 1, and I'm going to say, hey, use parameter y to specify parameter x, and define sub. And since we already know the concept of main, might as well make use of that. So we'll say define sub main, local x is a local, well, that's not, it's okay, we can use x. X gets initialized to 20, and then we invoke the subroutine sub2. We use x to specify parameter y, and define sub. Okay, let me fix all the indentations, and then we'll go ahead and trace this program and find out, what do we do when we pass a pass by reference parameter by reference to somebody else? Okay, here's the entire program, and we'll take a look at the trace. Okay. Well, the first part of the trace is pretty easy now that we know what passing by reference is. So we'll start with a column, a column for line number. There are no global variables anymore, see? Which is nice, okay? I personally do not like global variables, so this is good. And we start execution on line 14. When you move on to cisp300, there is no such thing as invoke main from the outside. The main subroutine simply gets triggered without you having to do anything. Okay, well, that's easy. We have to remember the return line number. In this case, it's post. And we also have to allocate for the one single local variable in main. In this case, it is x. starts with an unknown value, then we continue execution in the subroutine starting on line 11. X as a local variable starts with a value of 20, and then we call the subroutine or invoke subroutine sub2 on line 12. So far, I don't think we have anything that is mysterious. On line 12, we invoke sub2, so we have to do the same thing. The first thing is the return line number. There is a line after line 12 that I have to do when I come back, which is line 13. And then we have parameter y in sub2 that I have to specify. Parameter y is passed by reference. So when we pass, when we pass something to parameter y, we have to make sure that we can actually refer to that thing as an alias. Well, in this case, it's okay because x is a local variable in main. Okay, so x is a local variable in main. It has a column. In other words, x is the name of column C, and we can definitely say that y is an alias of the same column. So AKA, also known as column C, is an alias of column C. It's another name of column C. Are we doing okay so far at this point? Okay, when something is passed by reference, the parameter is an alias of the original item. Okay, no problem. So now we can continue execution in the subroutine starting on line 7. Now here is the fun part, okay? Because we are using a passed by reference parameter y, and we want to pass it by reference again to x. Okay. Let's deal with the easy part first, okay? Return line number is line 8, and we have to allocate a column for parameter x, and then we have to think about what do we do in column G? I mean, what is this? Well, there are only two quote-unquote logical choices. The first choice is x of column G, which is parameter x of sub 1, is an alias of column E, which in return is an alias of column C. That's the first choice. The second choice is column G is simply an alias also of column C. Okay?
Isn't it just the same thing? No.
So in the case of the call number,
Oh, okay.
how would you do it?
Probably with referencing E.
In other words, remember I'm a proofreader, but as a part of proofreading, I would subcontract, let's say spell checking to somebody else.
Yeah.
Okay, so you gave me the call number so that I can find the original book. When I want the spell checker to spell check that book, what am I going to do? Should I tell the spell checker where to find that little slip of paper that I have with the call number, or should I just make a copy of the call number and say, hey, here's the call number, go get that book yourself?
Have a reference.
A reference of what?
Have x be a reference of y.
X as a reference of y of column E, right?
Yeah.
Okay, so as a general rule, here's the easy part. We do not do a reference of a reference in this class. So that means X is an alias of what?
See that? Or
The original item, column C. When you pass a pass by reference parameter to somebody else by reference, you're just making a copy of the reference, which makes sense, right? Because if I'm the proofreader and I say, okay, I'm going to subcontract the spell check to somebody else, I'll just say, hey, here's the call number of the book. Go find it yourself in the library. Don't bug me anymore. Does that make sense? Kind of? Okay. So in this class, we do not do a reference of a reference, okay? In the C class, in cisp300, you might encounter things that are kind of like saying it's a reference to a reference, but not in this class. Yeah, when you guys get to pointers, which is about this time in the semester, next semester, it'll be fun. Pointers are kind of like references, except it's a little bit different. Okay, so now that we know what line 7 is doing, the rest is actually not too hard. Because when we get to line 3, which is the only line in sub 1 that actually does something useful, now we know what to do. Okay, on the right-hand side of line 3, we want to refer to x. So we look up, hey, which x are we supposed to look up? Are we supposed to look up column C right away, or are we supposed to look up column G? Column G, because it is the rightmost column with the label x. Okay, so you always remember, whatever is the rightmost is the one that you want to look up. Well, the good thing is, column G is a reference. It's referring to column C. So eventually we do go back to column C, so the 20 is the value here. 20 plus 1 is 21. We want to store 21 to x. So once again, we look up column G because it has a label x. But column G says, oh, don't store anything to me because I'm just an alias. Well, it's an alias of column C. So column C is the one that is going to be updated to a value of 21 on line 3. And then we're just going to unwind everything at this point. Line 4 is looking up the return line number, make a note, and then we deallocate both columns. And then now we are on line 8. Line 8 is also the end of a subroutine. And we look up the return line number, make a note, and then we deallocate those 2 columns. Now we are back onto line 13. Line 13 is also the end of a subroutine. So we do exactly the same thing. Look up the return line number, make a note where we are supposed to go next, and then deallocate those 2 columns, and we're done. Are there any questions about this trace? Just remember, in this class, we do not have the concept of a reference of a reference. Okay. Any questions about this? No questions? All right. Well, I think we can go back to factorial again and see if we can incorporate the latest and greatest concepts into that program so it looks better and we don't have to use global variables anymore. Question?
Now that you mentioned factorial, if you were to invoke main inside sub 1, would you then consider this algorithm recursive?
Yes. Recursion does not always mean the subroutine is invoking itself directly. In other words, you can have subroutine A that invokes subroutine B, but if subroutine B has a chance to invoke subroutine A, it is still considered recursive. So if eventually you have a way to go back to yourself, to invoke yourself, it is still recursive. All right, so let's go back and look at factorial again. Okay, define sub factorial. And this time we'll only make use of, we'll make use of everything except for global variables. We can't use everything except for global variables. Now we know that n is a inbox, okay, because I only need to get in, but there's nothing that the invoke statement needs to know about n when I'm all done. So this is an inbox, and my val is basically saying, okay, here's an inbox. It's not passing anything back to the invoke statement. On the other hand, we do have the result, which is something that we want to get back outside of the subroutine. So that one is going to be passed by reference. So n is incoming, r is outgoing. And in this case, I don't need a local variable. This is all that I need. So we'll do the same thing. If n equals to 0, then r gets a value of 1. Else we'll do the following. We'll say invoke factorial. We'll use n minus 1 to specify the new parameter n. And then we'll use r, my r, which is a parameter passed by reference to me. And we'll pass it by reference to the next subroutine, which so happen to be factorial itself. And when this is all done, r would have the factorial of n minus 1. So my job is easy now, because my job is simply to say, oh, okay, don't forget to multiply the value that I am given, which is n. And that is all that I need to do. Okay. And in this case, we'll have concept of main again. So we'll basically say in main, we have a local variable let's call it x to store the value, to store the result of the whole thing. We say invoke factorial, and we'll use 3 again to specify n, and then we'll use x to specify r, and define sub, and now we'll go ahead and trace the program. Does anyone want to trace this, or at least try to trace it without fixing the indentation first? No? Yes? We can try that once, okay? Because it's going to be a little bit more time consuming, okay? But I think it's a good exercise to emphasize why indentation is useful, okay? And remember, keep in mind this is a really, really short program. So just because we can trace this without indentation doesn't mean that you can trace a program in general without indentation. So we'll give it a try, trace this without indentation and then see whether you guys realize, hey, this is not nice. I mean, it's not convenient. All right, so we'll go ahead and try get started. We do need a comments column in this case because we have conditions we have one single condition to evaluate on line 4, and then we have line number. There are no global variables. So on line 4 as a precondition, there's nothing to say. The first line, I forgot about the invoke. Yep, I do have invoke factorial from outside, but I forgot about invoke main. So on line 15, we have to have a single invoke main on line 15 to get it all done. So this is where we start the execution of the entire program. When we invoke main, we have return line number being posed, and we allocate the local variable x as a result of that. Okay. Then we continue execution in main, starting on line 13. Okay, on line 13, we are invoking factorial, so we have to remember the return line number. Since the invocation is on line 13, the return line number is going to be line 14. No big deal. But we also have to remember to allocate for all the parameters. How many parameters do you think factorial has? It has 2 parameters. One is called n and one is called r. N is the easy one. What do I put here in column F? Go ahead. Yep, just the value 3 because we are now executing line 13, and the invoke statement says line n as a parameter should start with a value of 3. What about r? R is specified using x as a local variable. So r is passed by reference. So what do I put here in this cell? It's an alias, okay? So in this class, we just say it's also known as column D. Column D. Yep, that's it. Very nice. Okay, no big deal. Then we can now continue execution in the subroutine factorial, and starting on line 4. Line 4 is asking n equals to 0 is false because column F has a value of 3. So as a result, where do we go? Now this is starting to get a little bit hairy because without indentation from line 4, you actually have to scan the lines one by one to find out, oh, line 6 is else, so line 7 is where we have to go when the condition is false. Whereas before, it is a little bit easier to track because of the indentation. So without indentation, yes, you can still kind of scan it and find out that we have to continue execution on line 7, but it's not as easy anymore. But this code doesn't even have nested conditional statement. In other words, we don't have a conditional statement inside a conditional statement. Because if that were the case, then we have to actually count, okay? Because we might have to skip an if, and it's matching and if to get to the next one. So that's kind of saying, well, maybe indentations, is helpful after all, because this is a really simple program from the perspective, perspective of tracking it. Okay, so now we're on line 7. So what do we do on line 7? First of all, I'm going to show you a trick so that you can also do something like this. Well, you probably don't have to do it because your screen is probably big enough for this. Okay, when I move my mouse at the bottom of the screen, Some of you cannot see it. I'm gonna have to move the window over a little bit. Now we can all see it. Okay, when you move your mouse pointer all the way to here, basically between the horizontal scroll bar and this part here that is a dead space, it's not used for anything, it turns into a double-sided arrow. When it's turned into a double-sided arrow, you can drag it, and now you can split the screen this way. Okay, so once I split the screen, I can now say on line 7, we're going to allocate a column for return line number. We'll allocate one column for N and one column for R. Okay. The return line number is easy because the invoke statement is on line 7. We do have something else to do on line 8, so return line number is just simply 8. N is a little bit confusing because which N are we talking about? Because we do have one N here that is column F. It currently has a value of 3, and we are constructing another column with the label N. So what do we do with this N minus 1 specifies N? The left-hand side, the N minus 1, refers to column F, which has a value of 3, because that's what we already know. 3 minus 2, 3 minus 1 is 2. So what do we do with the 2? We specify that in column I. Is that part okay? And then R, what about R? I think we just encountered something like this in the previous example. Okay, I have a parameter passed to me by reference. I have a call number. Okay, now I have to ask somebody else to do some work with the original item. So what do?
Reference the original.
I make a copy of the call number and pass it on to the next guy. So R is the same as column G, which is just an alias of column D. Are we doing okay so far with how the columns are set up? Return line number, N and R. So okay so far? Okay. Now we continue execution on the first line in the subroutine that we're invoking, which just so happens to be factorial itself. So we have to go to line 4 again. N equals to 0 is once again false. No, we have to do this all over again. Well, that's exactly what it is. We have to go to line 7, and then we have to do the whole thing again. But this time I'm just going to do a copy and paste here. But we do have to remember to change the N to 1, because this time N minus 1 is referring to this N, which is column I. It has a value of 2. 2 minus 1 is 1, and that 1 becomes the value of the new column that I'm allocating here. And then we continue execution on line 4 again. N equals to 0 is no, because that means we have to do it again. Recursion. So on line 7, we have to do pretty much the same thing again, except this time N is 1 minus 1, which is 0. All right. So maybe we are done this time. Continue execution in the subroutine starting on line 4. N equals to 0 is true. And then on line 5, what do we do? Line 5 is easy. R gets a value of 1. Hold on a second here. R is
Column D.
Oh, it's just column D. It's not a reference of a reference of a reference of a reference of column D. It is just a reference of column D. Okay, well that's easy enough. So I'll just pull column D out and say, hey, okay, you have a value now. It is 1. Okay, and then we're gonna hide it again. That's the effect of line 5. After line 5, we don't execute line 6 because this is inside the conditional statement. When we're done with the then branch, we get out of the conditional statement, which is on line 9. Okay? Unless you know this code really well before this class, you probably have to scan to find an if. Now, if I had used indentations correctly from the get-go, you would not have to scan all those lines because you just kind of line up the indentation and say, okay, and if should have the same indentation as if and else itself, so it would just point you all the way to line 9 right away. You don't have to scan those lines anymore. But without the indentation, we actually have to scan through the line, and in this case, it's easy because we don't have any embedded conditional statement inside the conditional statement. So after line 9, we get to line 10, so it's time to execute line 10 at this point. Line 10 is just going to deallocate everything. Make a note that the return line number is 8. And here we'll use another trick to split the screen this way.
So you're going to save this and upload this when you're done, right?
The spreadsheet or the video?
The spreadsheet.
I'll answer that question later. Which is probably not what you want to hear. Okay, so we are still executing line 8. We make a note that we have to continue on line, we are still executing line 10. We made a note that we have to continue on line 8, and then we can proceed to deallocate all of these 3 columns. Just say, okay, time to deallocate, get rid of all of these columns. And now we are continuing on to line 8. But at this point, columns N, O, and P are now deallocated. So we have to kind of scroll a little bit back to columns K, L, and M. So on line 8, we have to perform a multiplication. It refers to R. R is also known as column D, and column D has a value of 1 at this point. N is referring to column L, which has a value of 1. 1 times 1 is 1, and we are going to store that back into R. R refers to column D, so column D is now updated from 1 to 1, which doesn't seem to do a whole lot of work, but the next one is going to be different. After line 8, which is the end of the else branch, we get out of the conditional statement. We continue on to line 10, and once again, we look up the return line number, make a note that we have to continue on line 8, and then we can proceed to deallocate these 3 columns. Okay. And now we're back on to line 8. Well, but this time when we're on line 8, columns K, L, and M are now deallocated. So we have to kind of roll over a little bit and use the other one to look up. Okay, one more, just scroll down a little bit more. There we go. Okay, now we're on line 8 again. On line 8, we have to evaluate the right-hand side first. The right-hand side refers to R. R is also known as column D. Column D has a value of 1. N is my pass by value parameter. It has a value of 2. 1 times 2 is 2. We store that into R. R is also known as column D, so column D is the one that is updated. Are we still doing okay so far? Okay. Okay, after line 8, we get on to line 10. Make a note, we continue on line 8, and then deallocate the 3 columns that we allocated. There we go. Now we are on line 8 again, but columns H, I, and J are now deallocated. So now we have to move to columns E, F, and G when we execute line 8. Line 8 is still doing the same thing, but this time to different columns. Because we have R, which is this R here, column G, it is an alias of column D, which refers to 2, which has a value of 2. N is my by value parameter, has a value of 3. 2 times 3 is 6. I store that value into R. R is also known as column D, and column D is the one that is updated to a value of 6. Then we move on to line 10. We make a note, we continue execution on line 14, and then we proceed to deallocate these 3 columns. Oops, wrong place to do it. There we go. And now we're on line 14. Line 14 is the end of the main subroutine. And we are now back to column C and column D. Make a note that we continue execution at post. And then we have no use of these 2 columns anymore. Deallocate. And we are now at post, finish line. Are we doing okay so far? This is another reason why I show that video of CAN blocks, because don't you kind of feel like that you just went through that course with a Segway and a Lamborghini and a spike ball? Now, when we are all done with this, I do want to show you what the whole thing looks like. Okay, I'm going to remove all the split screen thingies so that we can look at, just zoom out. Don't worry that you cannot read a single thing, but I just want you to pay attention to the shape. Okay, it's kind of the same shape, as factorial has always been. Okay, except in this case, we don't have a single use of any global variables at all. Okay, that's kind of nice because that's what we want, is to avoid the use of global variables. If there is something a subroutine needs to change and somebody else needs to know about it, use pass by reference parameters. Okay, that's what it's for. Oh, great. So we have all the pieces already. We only have 5 minutes left, and it's perfect timing. Well, not quite, okay? We have another concept that we have to introduce as far as subroutines are concerned. It's called a concept of a return value. But why do we need return values? Well, I'll just give you a quick example to illustrate why, even though pass by reference is useful, it is cumbersome in some cases. Okay, so I'm going to give you this example as the introduction to return values, which we'll talk about on Thursday after the practice exam. Okay, so let's go ahead and define a subroutine called add. Okay, but you guys would say, but why do we need to define add? Those we already know how to add. But maybe sometimes we want to define a subroutine add for complex numbers, for vectors, matrices, and other types of values. So it's not uncommon that we might need to define a subroutine that do some kind of addition operation. So we already know that in order to add something, you will give it two values to add. So in this case, we'll say x and y are the values that you're adding, and we know there's a sum. So we'll go ahead and use by reference sum as the answer. Okay, the rest of this is easy, right? Sum is x plus y, and define sub. Done. So we can now avoid the use of global variables and yet be able to pass the result of a calculation back to the line that is invoking this. Okay, so what is bad about this? Okay, let's take a look here. So define sub main, and let's say I'm using this symbol here to mean comments, which means it's not code that you execute. It's just me making a note of this particular program. So let's say we want to calculate 23 plus 67 plus 102. Okay, this is what I want to do. And I cannot just use the add operator. I have to invoke the subroutine add to get this done. Okay. Well, it's no big deal. We know how to do this. We can just allocate a local variable to store the result of the addition. So we just call this result here. Then we can say invoke add. And the first time we'll just pass 23 as x, we'll pass 67 to y, and then we pass result to store the sum. And then we'll do it again, okay? We'll have to invoke it again. And then the next time we basically have to pass the result of the previous summation to x, right? Because we have to kind of chain this whole thing. And then we pass the third number, which is 102 as y. And then we pass result again by reference to store the sum, and done, right? But this is really cumbersome because what we want to do is to say, but this is what we really want to do, which is saying, somehow I want to say the result is the addition of 23 and 67, and then take the result of that and just go ahead and add 102 to it, and by invoking sum again, something along this line. Okay. Do you guys understand what I'm trying to write here? Okay. Doesn't that look a little bit like how we usually express addition? Okay, I'm just going to use the whiteboard. We have exactly 2 minutes, but I think it's enough time to talk about this. When we use 23 plus 67 plus 102, we can use additional parentheses to make it clear, of the order of the addition. Even though in this case we can use the associative property and say, we can reorder this whole thing any way we want. Okay, but this is the typical way of using what we call an infix notation, which means the operator that tells you what we're doing with the value is in between the two values that it needs to do the operation. That's why it's called an infix notation, because the operator is between the two values that it has to operate on. Is that okay? And this is how we were brought up. I mean, we understand this notation. The other notation, so this is called infix notation. Another notation is called prefix, okay? And some of you probably already know what prefix is. It's the operator being the first thing. So in this case, if I want to use a prefix notation, I would say, okay, we want to add 23 and 67 first, and then we take that result and perform another addition with 102. This is called a prefix notation because we indicate the operation first, and then we specify what it is operating on. Are we doing okay so far with the prefix notation? Well, we got in, we got pre. What do you think comes next? Post. Okay? Postfix. The postfix notation in this case is really funky because what it's going to do is to say 2367, do an add, 102, do another add. That's the postfix notation. You specify the numbers first, and then you say, oh, by the way, I want you to add the previous two numbers. So after this add, you have one number left because you're adding the two, getting the sum. Whatever the sum is, you ignore that for the time being. You specify a new number, 102. Now we have two numbers again. And then you say, oh, I know you have two numbers on your hand. Okay? Do an add and give me a single answer. That's the postfix notation. Which one do you think I liked the most? Postfix. Why do I like postfix the most? There are no parentheses. Has anyone encountered postfix before? What was the in math class? They do. They talk about postfix. Before we had TI calculators, which brand? What was the prestigious brand name of calculators before TI took over?
Casio.
Well, Casio got the low-end market. The high-end market had.
It's that weird one that you had to type everything in backwards.
Yes,
Was it
it's
like-
HP.
yeah.
Okay,
Yeah.
HP, Hewlett Packard used to make high-end scientific calculators that use the postfix notation. There are no parentheses keys on those calculators. You specify the operation using this method, and there's no need to use parentheses. And that's why there's an entire generation of engineers who probably would be around my age or older who can look at an infix notation, no matter how complicated it is, and in their head, in their mind, they can do a translation into postfix like, oh, okay, like that. There's an entire generation of engineers who can do that, which probably are close to retirement age because I have Casio calculators that did have parentheses already. But this is also significant. Has anyone heard of postscript? Okay, some of you, when you go buy a printer, sometimes you will encounter the term called postscript, which is a language for your computer to talk to your printer. It basically says, okay, instead of saying, okay, we want to place pixels here, here, and here, and here, and here, it's saying, oh, draw a line from here to here. Okay, so now it's the same command going to a 300 dpi printer, 600 dpi printer, or 1200 dpi printer. Doesn't make any difference because it's just saying from here to here, draw a line of this thickness. That's it. Okay, the term postscript comes from postfix because that's how they specify the operations. Okay, specify the coordinates, then you say what to do with those numbers. But many of you do not know that. How about PDF? Do you know what is PDF? Portable document format? That really is still postscript behind the scenes. So that's why postfix is actually quite useful. We are still using it behind the scenes, in a lot of applications where you have a machine to talk to another machine. Because when you have a machine talking to another machine, there's no need to go through all the extra steps and all the extra parentheses to specify operations. This way, there's no need to use parentheses. It is really easy to parse this particular language. So that's it. I overran by 3 minutes or so. I hope your dinner won't be cold.
What about the email in the class? Was it something, the email in the beginning of the class? Do you send out the email for the homework?
It's just an exercise for you guys to
Just for
do,
practice?
but I don't want it back. I don't want to grade it. So,
I didn't. Alright, thank you.
All right. Yay. This. Okay. Okay. Got it. I think you did pretty good in this class. Yeah. So this is cisp300. All right, and this is for. Oh, okay. All right, cool.